In this brain bit by bit, I'm going to show images of a newly classified epileptogenic lesion with mainly white matter abnormality. And this entity is called MOGHE and was added to the classification from the International League Against Epilepsy last year. And I've already shown images of focal cortical dysplasia type 2 and focal cortical dysplasia type 1 in previous vlogs. And sometimes a small focal cortical dysplasia escapes visual attention on MRI. And for that reason, several post-processing methods have been developed. And one of them is a program that is used in many hospitals, including the one I work in. And that's called Morphometric Analysis Program by the Swiss group led by Huppert's. And what this program does is that it compares the 3D T1 and 3D FLAIR scan of the patient on a voxel to voxel basis to a normative database, and it highlights the regions that might be abnormal on different feature maps. So on the junction image you can see if the gray-white matter boundary is blurry. On the thickness image you can see if the thickness of the cortex is aberrant, and on the extension image there's abnormal extension of gray matter into the white matter. And there are a lot of false positives with this program, but it can really help you because it points out certain regions and you can pay special attention to these regions, especially if they are concurrent with the semiology and EEG findings. And there are sometimes abnormalities that are even more subtle than typical FCDs, pointed out by this program, where you have, for example, some cortical thickening or some subcortical hyperintensity, but not all the FCD features. And this might be a new entity, namely the MOGHE, and it was described in 2017 as a new entity, but if you look in literature, there was already an article in the American Journal of Neuroradiology 2009 where they had an MRI at 3 Tesla, which they called high field strength at that time, with some abnormalities in the white matter in a patient with epilepsy, and they already named it oligodendroglial hyperplasia. So it's not a new entity, but it has been classified recently. And when I talked about the focal cortical dysplasia and the background, I mentioned that in focal cortical dysplasia type 2 there's a problem with the mTOR pathway. And in focal cortical dysplasia type 1, there's often another underlying mutation, often in a gene that encodes for a galactose transporter, a transmembrane protein, previously called congenital disorder of glycosylation CDG2M, and now called SLC35A2, which is a very difficult to remember name. And in MOGHE you often have the same mutation as in FCD type 1. So there's not a problem with the mTOR, but with this unpronounceable gene. And on histology, there's normal cortical lamination in MOGHE, as you can see in this staining for the neuronal nuclei. But there is an abnormality with the oligodendrocytes on this oligo2 staining, and there are too many oligodendrocytes in the subcortical white matter, and this gives the impression of a thickened cortex. So on MRI, the cortex looks thickened because of the oligodendroglial cells in excess superposed on the normal cortex, but on histopathology the cortical thickness is normal. And since it has been classified and since it has been described, there are many articles describing MOGHE, another example with hyperintensity in the subcortical white matter in the right temporal region with a sharp gray-white matter boundary. And these articles state that it's an underdiagnosed entity and it's probably more widespread than you think. And another interesting thing is that there's often an abnormal cortical folding, so some mild dysgeuria in the case of MOGHE. This is another case of MOGHE with left frontal lobe epilepsy with an abnormality on the MRI with thickening of the cortex, and after staining for the oligodendrocytes on this zoomed image, you can see again the excess of oligodendrocytes, so oligodendroglial hyperplasia. This is a schematic drawing of MOGHE where you can see the excess of oligodendroglial cells and some heterotopic neurons in the subcortical white matter. And MOGHE is primarily a white matter disease, but because on imaging you might misinterpret it as a cortical dysplasia, it is included in this new classification from the International League Against Epilepsy. Thanks for watching. Until next time, when we will continue with an inflammatory white matter disease, multiple sclerosis.